Hello everyone, this is Unit 3, Lesson 6. I can construct and interpret patterns in two-way tables by using relative frequencies. So this is a two-way table down here, and you could see that it has boys, girls, school dance, faculty, student basketball game, and total. Lori surveys students in a homeroom to find out what upcoming school event they're most excited about. Her results are shown in this two-way table, and it says which statement is supported by the data in the table. So if you look at the choices, it says if you randomly select a boy from a homeroom, he's more likely to be excited about the dance than the game. So if we have, if that's true, there's no way that the boys would be 8% and then 42% for the game. So that's false. So you could go ahead and cancel that. If you randomly select a girl from a homeroom, she's more likely to be excited than the game, about the game than the dance, and they're split. So that cancels. And that's false. If you randomly select a girl from a homeroom, she's more likely to be excited about the dance than the game. We already went through that the girls are split basically down the middle with 25% dance, 25% looking forward to the basketball game. So that's out and that's false. And D, it says that if you randomly select a student from a homeroom, just a student, he or she is more likely to be excited in the game and the dance. So just take a look at all the students. They're more likely to be excited about that game. So that's the only one that's true. So D is your answer. We're talking about two-way tables. We're talking about data that shows from one sample group as it relates to two different categories. This is really statistics, and they're asking, this is always survey being asked of like kids or homerooms or like students or adults or whatever it is, about something that they like or they don't like. So one thing that you do have to understand that columns go up and down just like this, and rows go side to side horizontal. So columns up and down, rows are across. This table shows relative frequency. Relative frequency is the ratio of the number of people divided by the total number of people asked in a specific question. Just remember, don't start getting nervous about a relative frequency. It doesn't sound like anything that you've ever heard of. Relative frequency is just a fraction, and then when you divide that fraction, you get the decimal, right? And then you turn that decimal into a percent. So that's all we're going to do, no matter if they say find the percent of or find the relative frequency of. It's all the same thing. So if we take a look at this example, workers in a large company took part in a voluntary survey, and there it is again, about a political party they support. Results are shown in the table. There's one thing that is missing, and it's the total column and the total row. So easy, when we kind of are adding up the totals, we're just going to go ahead and add all the way across. Now, let me get this over here. All right, so for the Democrats, we have 37 plus 15 plus 22 plus 31 plus 42. If we add all that up, we get the total. So I'm going to go add all of that up, and I'll put the totals down. So I added up all of the columns. 37 plus 12 plus 5 is 54. 15 plus 25 plus 7 is 47. And so on and so forth. I added up all the rows. We have 200 in this spot right here. We're talking about 275 people took part in this survey. So that's how that's the first question. How many people took part in the survey? It is 275. How many Democrats and independents took part in the survey? Democrat, all the way across, there's 147 of them. And then independents, that's 34. So you take your calculator and you do just put this up a little bit, 147 plus 34. And that's 181 as a total. Democrats and independents. What percentage of Democrats came from the Midwest? So every time that you have a question like this, you just have to remember you have to create a fraction and it's part over whole. So the one thing that you have to remember is that the bottom number has to be known before you put in the top number, your numerator. So the denominator is very important. That's the whole amount. That's the amount that you are asked to create the percentage from. So it says what percentage of the Democrats. So of the Democrats. So let's talk about Democrats all the way across. It is 147. So I'm going to put that, there's Democrats, 147. Came from the Midwest. So how many Democrats, how many of these people, 147, came from the Midwest? It's 22. So I'm going to grab my calculator again. And I am going to put 22 divided by 147. And I'm going to get 0.149. And if I'm rounding this to the nearest percent, I'm going to take 0.149 and I'm going to move the decimal over 2 places. And that becomes 15%. It's 14.9. 14.9 gets rounded to 15%. How many Democrats came from the Midwest? 50%. 15%. All right, so let's talk about this. This is a survey about compact cars, mid-size, full-size, all drivers on what they own. It says, what percentage of middle-income earners? Stop. Middle-income earners. So let's talk about middle-income earners, 106. Out of those people, how many owned compact cars? So let's talk about 106 out of these people. How many owned compact cars? 28 of them owned compact cars. So I'm going to grab my calculator and I am going to put 28 divided by 106. And it is, I'm going to put an arrow, 0.264. It says round to the nearest whole percent. So the final would be, I'm going to move this over 2 places. That would be 26.4, and it stays 26%. What percentage of the total group? Total group, 283. Denominator. Owned luxury cars. So of these people, how many people owned luxury cars? 54. So it's 54 divided by 283. Enter. I'm going to put an arrow, 0.190. And that is 19%. Going down a little further, what is the relative frequency of compact car owners? Stop. Compact car owners, 72. Who have low income. Let me max up. Compact, of these people, 34 of them have low income. So now we have 34 divided by 72, and we enter, and it is 0.472. So that is 47%. Very easy. You're going to just add these down to get the numbers that are missing. This is 295 and this is 145. They have the totals, so let's go and get started. Of the students who are not on the honor roll, so we're going to talk about not on the honor roll, approximately what percentage did not play a sport. First, we have to say not on an honor roll. Not on the honor roll, 75. So we're going to just put down 75. Out of those kids not on the honor roll, what percentage did not play a sport? Did not play a sport? 30. So we have 30 over 75, and we're going to round it to the nearest tenth. Now, 30 over 75. Nope. So 0.4. 0.4. And that's 40%. Remember, you're moving that decimal over 2 places to the right. Of the students who play a sport, all right, 295. What percentage are on the honor roll? On the honor roll, 250. That's a high percentage. So 250 divided by 295. And we get a 0.847. We're going to move it over 2 places, and we have 84.7%. And I know I said round to the nearest tenth, but let's go round to the nearest whole. 85%. And that's it. So Eloise surveyed the students in our cafe and found 38 male students agree with the cafeteria rules. 70 do not. So let's stop there. 38 male students agree with the rules. 38 male students, and then 70 do not. There were 92 females surveyed. So I'm going to find females, 92. 41 of them agree with the new cafeteria rules. Agree. So now we have enough information that we could just go ahead and add, and that's what I'm going to do. 38 plus 41 is the first thing that I'm going to be doing, and that is 79. So the total is 79. Then I have 2 in a row right here, so that's 38 plus 70 is 108. Then I have 2 with 1 missing in the middle. If I subtract these two, 92 minus 41, I'll get the one that's left over in the middle. It's 51. So it's 70 plus 51 is 121. 108 plus 92 is 200. And you, just like that, finished the entire table. All right? Of the male students surveyed, male students only, 108. So I'm going to put that as the bottom part of my fraction. Of the male students surveyed, approximately what percentage of male students disagree with the rules? All right, so out of 108 students, how many disagree with the rules? 70. So 70 over divided by 108. So we're going to have 0.648. So 0.648. That's just bad. .648, a little bit better. And that is 65%. Move that decimal over 2 places to the right, and you get 64.8%, and that rounds to 65%. Of all the students surveyed, 200. Approximately what percentage agree with the rules? So let's see, 79 of the 200 agree with the rules. We need a calculator. 79 over 200 divided by, and that is 0.395. 0.395. And if you move the decimal over 2 places, you get 39.5. And that, if you're rounding to the nearest whole percent, would be 40%. Find the percentage of female students who agree with the rules out of the total number of students surveyed. So the total number of students surveyed is 200. So percentage of female students who agree with the rules, out of the total number of students surveyed. So total number of students surveyed, agree with the rules, female, 41. So 41 over 200 is 0.205. If you move the decimal over 2 places, you get 21%. 20.5%, and you round it to 20%. 21%. The mid-lesson assessment on a poll, 150 students were asked, there's 150 right here, if they prefer camping or going to the beach, and summer vacations, and the agenda. The data shown in two-way frequency table and the relative frequency. All right, what is the relative frequency of students who prefer going to the beach among all of the students polled? So 150, all students polled. Students who prefer going to the beach, 90. So we're going to grab our calculator. We're going to do 90 divided by 150 is 0.6. If you move that over 2 places to the right, you get 60%. And that is your mid-lesson assessment, D. All right, so this Explore School Club had a t-shirt sale to raise money. After the sale, the inventory showed that 108 blue t-shirts and 96 green t-shirts had been sold. I'm going to stop right there, and I'm going to use my choices to see if a table shows 108 blue t-shirts. So I have 60. I'm going to just take the calculator, and I'm going to add 60 plus 86 plus 58. 86 plus 58. Enter. 204. So this total for the blue t-shirts here is 204. They said that 108 were sold. This can't be the answer. All right, so that's out. I don't have to check anything else. All right, let me grab my calculator, and I'm going to do the same thing now with B. So I have 34 plus, I'm going to just do the blue, 34 plus 46 plus 28. 108. So this is 108, this total. So that works because it says 108 blue t-shirts. All right, I'm going to move this over. Blue, I'm going to go right across there from the row, in that row. 30 plus 43 plus 29. Enter. 102 total. So the blue t-shirts, 108, that's out. Let's talk about D. 26 plus 40 plus 30. Enter. 96 total for the blue on the table D. That's out. It needs to be 108. The only one left is B. The only one that says 108 blue t-shirts is B. And if you look at the green, 26 plus 40 plus 30, that would be equal to 96. And obviously, that's right there. You don't have to check anything else. That's it. So I would check one thing at a time and cancel out the tables that make sense for you to cancel out. And B is your answer for that one. Okay, so we have this type of question here, and you could find this on the Regents for sure. It says the principal of a school of 475 students collected information about how many students wear glasses. Of the 475 students, 52% were female. So 475, and you just change that. All you have to do is change that percent to a decimal. So you're going to move this decimal over, that's at the end of the number there, 2 places to the left instead of 2 places to the right, which we were doing. So we're going to just take 475 now. I'm going to clear this out. Times 0.52. And we have 247. So 247 were female. And what I'm going to do right now, I'm just going to go ahead and subtract right here 475 minus 247. Because I want to get this number right here for the male students. So 275 minus 247. And I have 228 males. All right. So of the 475 students, 24% always wore glasses. So I'm just going to take the 475 times 0.24 and see where that brings me. 475 times 0.24. And that's 114. So 114 of those students, so this is 114, always wore glasses. So 114. And half of those students were female. So that means half, you just could divide it by, if you take 114 and you just go times 0.5, you get 57, or you could divide by 2. and they were female 57. But if you think about it, if half were female, half had to be male. So we're just going to put 57 here also. You could do 114 minus 57. It would still come out to be 57, all right, for the male students. So right there, we could just do 114 minus 57, and you know that you would get 57. All right, so let's go. And of the 70 students who never wore glasses, 70. 2/5 of them, 2/5, so 70 times 2 over 5 were male. Enter. 28. So if this was 70 times 2 over 5, and we have 28 down as those students were male, 28, I could take 70 minus 28 right away and get 42. 70 minus 28, and that would equal 42. So that means 42 of them were female. Now, we don't have 2 columns. We have 3 columns to add up to a total. So what we have to do is I'd like to get all of these numbers right here. We have to add the 50 plus the 28. So 50 plus 28, and then you would get 78. And so these two, when you add them up, would be 78, and then you subtract the 228 from it. So 228 minus the 78 would be 150. So you get that like this plus this plus this. 57 plus 150 plus 28 should be equal to 228. All right, let me try this again. Just like I'm adding these two right here, this 57 plus 28. And you can see on my calculator that equals 85. And then I took 228 minus the 85, and this is 143. So I made a mistake with those numbers there. So this is 143. I'm going to do the same with the females. 57 plus the 42. I'm going to enter it as it's 99. So then I'm going to take the 247 minus 99. And I have 148 here. Take the same thing with the totals. Actually, I don't even have to, but we could do it. We could just add it down. 143 plus 148. $143 plus 148 would be 291. All right, so I know that this adds up, this adds up, this adds up. But I'm going to just see if 114 plus 291 plus the 70 equals 275, and it does. All right, so that's it. So we're going to answer some questions now that we filled in all of that table. Of the students that sometimes wear glasses, so sometimes wear glasses, of those students, so there's 291 of those students, what percent were female? So 148 sometimes wear glasses. So I'm just going to take 148 divided by 291, and it says round your answer to the nearest whole percent. So we're going to just bring that back up, and it's 0.58. Nearest whole percent would be 51%. round all of the students in the school. So we're just going to go ahead and put that number, all of the students, 475. What percent never wore glasses? Never wore glasses. 70. Wow, not that much. So 70 divided by 475 is 0.14. So we're going to put down 0.147. And the reason why I have that number down there is that I'm going to round it to the nearest whole percent, and that rounds to 15%. If you move this decimal over twice, it's 14.7. That's 15. All right, and that is finished. So here are some Regents questions for you. Again, some of them, like these two questions here, they do not have the total column or row. So the students were asked to name their favorite sport from a list of basketball, soccer, or tennis. The results are shown in the table below. What percentage of the students chose soccer as their favorite sport? So I'm going to have to do some like addition here to get the total. One thing I do want to make sure of is that I have the correct numbers. So I'm going to do 42 plus 58 plus 20 on that first row, and I get 120. And then I have 84 plus 41 plus 5, and I get 130. So it looks to me that I have 250. Right, so if I could 42 plus 84, 126. I need the soccer column anyway, so 58 plus 41, 99, and this is 25. So this plus this plus this is 250. So it works out. So what percentage chose soccer of all the students? So 250, all students, and out of all the students, 99 of them, which is pretty substantial, chose soccer as their favorite. So this is 0.396. If you round it, if you move that decimal over, you get 39.6, and that is that. All right, so students ask their peers about their TV programming preferences. The results are shown in the table below. Based on the sample, predict how many schools, of the schools, 351 males would prefer drama. So this is a little bit of a tricky question. And the reason why it's tricky is because there's something here that is a little bit, that doesn't happen usually on regular questions. So it doesn't happen. But let's go ahead and figure out the totals, because we do need that total. And just to get things a little bit in perspective here, it really doesn't matter. This is 351. Let me not put that. Let me add them up. So out of the males, 70 plus 35. So 105. $48 and 42. Add them together. You get 90. 90 plus 105. Could have done that in my head. 195. So that's the total. Then you get 70 plus 48. This is 118. This is 42 plus 35. You get 77. So everything's total is ready. So students ask their peers about TV programming. Based on the sample, predict how many of the school's 350 males would prefer drama. So I'm just going to go by what the table says. In the table, in this survey, they only surveyed 105 males. So they surveyed 105 males. How many of the males preferred drama out of that 105? 35. So the best way to do this is to set up a proportion, because you don't know, like if they're saying that 351 males are in the school, that means the sample is less than the 350 males. In other words, they didn't go to every child. They didn't go to every student and ask them, do you like drama? Or do you like comedy? 351 was too much, so they cut it down. They only went to 105 males. So since they only went to 105, that means the 35 over 105 would yield a percent, and then you would have to multiply that percent to 351. All right. So there's a couple of different ways to do this. I like doing it, setting up this proportion. So there's 35 males that like drama in this survey. We don't know the amount of males that would like drama out of the 351. So once we set that up, it's doing, or that butterfly method, 105 times x, which is 105x. And then 351 times 35 would be 12,285. Divide that by 105, and you're going to have your answer. So divide by 105, and you get 117. $117 males would prefer drama. The other way would be 35 divided by 105. Get the percent, but the thing is the percent doesn't come out perfectly. But so you would have to take that and then multiply it by the 351. And it wouldn't come out perfect because, again, it's 1/3. So if it is 1/3, let's see, 351 times the 1/3, which, and yes, it would come out to be 115, or, so I'm going to put or, 35 divided by 105, and that is 0.33333333. It equals 0.33 with a line on top. And then you would take the 351 males and times it by 1/3. You can't even do 0.333 because it's rounded. Really is rounded. And so then that would come out to be 117. So either way, this is the second method that I would use. This is the first method, set up a proportion. And I think that's much easier to figure out. All right, so here's another regions problem. And here we go with this. This is a public opinion poll. The result of the poll summarized below. Round to the nearest 1/10%. what percent of the 41 to 60 age group were for the candidate? So I'm saying for the candidate, what percent? So I'm going to have to get some totals here because I don't know the bottom part of my fraction. So 20 plus 40 is 60 plus 15 is 75. So I know that this is 75. 41 to 60. How many of these 75 people were for the candidate? For 20. So 20 divided by 75 is 0.266. I'm going to round it to the nearest tenth, and I'm going to put 6, and I'm going to keep on going. And this is 26.7%. Rounded. What percent of the 21 to 40 age group, so this is 30 plus 12, which is 42, plus 8, which is 50, had no opinion? So out of 50 people, how many had no opinion? 8 out of 52. So let's talk about 8 divided by 52. And that is 0.1538. If you round that to the nearest tenth, I'm going to bring that to 15.4%. And that's that. What percent of the total voters were against the candidate? So I'm going to just add these down. And this is, I can't add them down. So I have to see 25 plus 35 plus 15. So that's 75. And now I'll add them down. 150, that should be 200. Again, if you want to check, you could check it, but total voters, 200. Again, if you add these down, this is 50, 75. This is 75, 85, 87. This is 38. All right, so if you add 75, 87, and 38, that's 200. All right, so what percent of the total voters were against 87? So I'm just going to take this calculator, 87 divided by 200. And you get 0.435, and that looks like 43.5%. Round to the nearest tenth. And that's it. All right, assessment exit slip. In a poll, 100 people were asked. They give you the totals. This is great if they like to prefer drive a truck or a car, and their gender. The data shown is in the two-way frequency table. Based on the table, which statement is not true? Okay, here we go. Women are more likely to prefer driving cars than men. See, women, cars, men, 28. That seems true. And it is. 38, 36, 28. Men are less likely to prefer driving trucks than women. Trucks, men are less likely. No, men are more likely. So this is false. So that looks like it's my answer. I'm just going to go and put a line under it and just keep on going. Women are less likely to prefer driving trucks than men. Yes, that's true, because 12 women versus 24, that's true. And men are less likely to prefer driving cars. Men are less likely to prefer driving cars than women. All right, that's true because there's 28 to 36. So the answer is B, and that's that. All right, just got to be careful when it says not. All right, it says try this. All right, just be careful with these types of questions. These are the questions that you are going to get on the regions. So here we go. Josh surveyed 225 classmates at the school. 225. Of the 225 students, 44% were female. 225 times 0.44. 99. So 225 times 0.44 is 99. So 99. All right. 64 students said their favorite animal was a horse. Oh, very nice. I like it. 64. And then 1/4 of those students were male. So 64 times 1/4, which is 0.25 if you wanted to convert it into a decimal. So 16. 1/4 of those students were male. So I'm just going to do some quick subtraction and everything. 64 minus 16 is 48. So I'm going to put 48 here. And then I'm going to do 225 minus 99. And obviously that's 126. Oh, I got some more numbers. All right, we have that done, and we have this done. So 64 times 1/4. And that equals 16. 110 students who said dolphins were the favorite animal. 60% were male. So out of the 110 times is 0.60. 0.6, doesn't matter. 110 times 0.6, please, okay, is 66. So 66. So I'm just going to do some quick subtraction. 110 minus 66 is 44. Then I have to add these two numbers and then subtract from 126 to get the penguin. Yeah, that's it. So 66 plus 16 would be 82. Then I take 126 minus the 82 and you get 44. Congrats. All right, then 48 plus 14. Was that 14? 44. 48 plus 44. That was close. Is 92. So 99 minus 92. 7. Like females don't like penguin. Who doesn't like a penguin? And then we have 64 I love penguins. 174, and then you get 225 minus 174, and you get 51. All right. So that's about it. So you filled in that table. Of the number of students that picked penguin as their favorite animal, what percentage were female? So of all the students that picked penguin as their favorite animal, 51 was the total amount, and then 7 of the females picked penguin. 7 over 51 is 0.1372. If I rounded that to the nearest whole percent, that would be 14%. Rounded to the nearest tenth would be 13.7. All right, and we are finished with that lesson on two-way tables. Hope that helped, and I'll see you next time. Thanks for watching. Bye.